In this video, we want to study some basic rules of differentiation, right? Good. Okay, so in our previous video, we dealt with the derivative of a constant, so we have it to be c, which denotes a constant. So when the function is just a constant, the derivative is just going to be 0. We should check that out, okay? Good. And then we checked again the derivative of power functions. When you see a function of this form, x raised to some power, then you can apply this rule and get the derivative just immediately. Good. And now in this video, we want to look at the third one, which is the derivative of a function with a constant multiple. So this is c times a function of x, all right? So that c there multiplied with the function part is actually what we call the constant multiple. So when we have a constant multiple with a function, we want to see how the derivative is. Well, from this rule, we have it to be that whenever we multiply a constant with a function, that the derivative is going to be keeping the constant, all right? We do not touch the constant, we just keep it, and we multiply it with the derivative of that function. So this f dash of x, all right, this dash here shows that this new function is gotten from this old one, all right, by differentiating it. So if you see something like dy dx, it is the same thing as saying y with a dash, right? Be that the derivative of function, if a function is called y, and you're differentiating that with respect to x, so that the dy dx is the same thing as y with a dash, all right? So this is the same thing as differentiating the function f of x. Good. So when we have a constant multiple function, you just keep the constant and differentiate the function. Okay, so we have the following examples which will best illustrate what we just talked about. So we have the first one to be 3 times x raised to the power 3. So here we have the constant to be 3, just as the c, and then we have the function x raised to the power 3, just as the f of x, right? It's a function written in terms of x. Good. So when we want to differentiate that function, we'll just apply this rule. So you keep the 3 constant. Okay, so I'm going to put it down this way, that the derivative with respect to x of that function, which is 3x to the third power, is going to be, this rule tells us, keep the constant, all right? Just keep that c, do not touch it. So we keep this 3 as it is. And then we multiply it with, now, you now differentiate the function, all right, which is f dash of x. Now, look at the function that we have here. That is x raised to the power 3, which is actually a power function. So to differentiate this power function, we refer back to the power rule, all right? Which tells us bring down the 3, okay? We bring down the power. In fact, let me do this, which is 3, right? And then subtract 1. We multiply with x, and then subtract 1 from that power. That will become 2, all right? Get it? That is, when we keep the constant, okay, we didn't touch it. When we differentiate this, we keep the constant, which is just the 3, and then we now bring down the power, okay, and we subtract 1 from the power. Good. Okay, so maybe we can simplify this further. This will become 3 times 3, which is just 9, and then x raised to the power 2. So this right here is the derivative of that first function. Great. And now we have the second function real quick. We have just 5x, all right? So differentiating this function, let me put it down this way, the derivative with respect to x of that function, just 5x, right? Okay, good. Well, this is going to be, you look at it again, we have c here, so we just keep down the constant, all right? So this is just the constant, we're just going to keep it, so this will become just the 5. Then we multiply that with the derivative of the function part, right? So this is a function, we're going to differentiate that. So the function we have is just x, right? Which is just a power function. It's just like saying x raised to the power 1. So differentiating that, we're going to just have to bring down the power, okay, using the power rule, bring down the 1, and then multiply with x, right? So, and then reduce the power of x by 1. So we're going to reduce the power which was 1 originally. We subtract 1 from that. Well, that tells us that the power of x is just going to be 0. And raising x to the power 0, okay, the result there is going to be 1. So all in all, we enter with 5 times 1 times 1, which is just 5. So the derivative of 5x is just 5. Good. And now we have another function here, which is x to the second power divided by 2. Well, we have to put this in a fraction form, right? But we want to put it in this form, which is just a constant multiple. Well, this is not too hard to see. This 2 in the denominator, I can push it off, and we can have it to be 1/2 of x squared, right? It's the same thing. Okay, so now we have a constant multiple, which is 1/2, and we're going to differentiate this function with respect to x, So doing that, we are going to have to keep the constant, all right? We keep the 1/2 and then differentiate the function part. Well, we keep the constant and then the function part is just x squared. Differentiating x squared, we're going to have to bring the power down, all right? So first thing, we bring down the 2, then put down the x, and then subtract 1 from that 2, all right? So we have it here to be 2 minus 1. And simplifying that further, we're going to enter with, well, 1/2 and 2, you know, these are 1/2 times 2 is just going to be 1. The two of them cancel, and then we enter with just x to the 2 minus 1 is just 1, right? So the derivative of the constant, x squared over 2 is just x. So that right there is the derivative. Okay, this is the derivative. Good. And then lastly, we have, this function is a little bit complicated, but it's very nice. Okay, we have 1 over 2, then the square root of x. Well, this is actually the derivative of square root of x. So we want to differentiate this function again. Good. First thing we need to do is to rewrite this function such that it has the constant multiple form, all right? Just c times f of x. So I'm going to pull out the 1/2 in front, and then I multiply it with, well, this is going to remain with 1 over the square root of x. All right? If you multiply this back, you get these back, all right? So we've got the constant multiple in front, and then we need to get this straight, all right? We can take that to a power form, that is x raised to some power, if we perform some exponent rules on that. Good. Well, here, I'm going to rewrite this as, I'm going to put down the 1/2, and then 1 over times 1 over, this square root of x can be written as x raised to power 1 over 2, right? So you put it down like that. Okay, good. And since we have x raised to some power in the denominator, and the numerator is just 1, okay, this reminds us about the negative exponent rules, which we are going to put down this as 1/2, then x raised to power negative 1/2. Okay, good. So it's that negative exponent that took that x raised to power 1 over 2 to the denominator. Great. So we've got that to be a power function times a constant. Okay, that becomes a constant multiple with the power function, and we can do some differentiation of that. So let me just put it down here. The derivative with respect to x of the whole of that, which is 1/2, then x raised to power negative 1 over 2, all right? This is going to give us, okay, so let's see what we've got. We have a constant multiple right here, right? So differentiating this, we're going to put down the constant without touching it, and then we multiply it with, well, we're going to bring this power down, all right? The power is just negative 1/2. We're going to bring negative 1/2 down, okay? And then multiply with the x. So you multiply that with x. And the next thing we'll do to that power function is to subtract 1 from it. So the power function is already negative 1/2. So we subtract 1 from that, okay? Good. So we have to simplify this further. Well, 1/2 times negative 1/2, that will give us 1/4, right? So we're going to equate this to 1/4. Then together with the negative sign, that's negative 1/4. And then, well, we subtract 1 from 1/2. So negative 1 over 2 minus 1. Well, that's just negative 3 over 2. You can perform some subtraction of fractions on the power, and that will give us negative 3 over 2. Okay, good. And then we can bring this down into a nice form, okay? That would give us negative 1 over 4 times the square root of x cubed. I believe this is okay for you. Right? So we have 1 over 4, which is 1 over 4, then the negative sign. Then this 1 over square root of x raised to the power 3 is just from the exponent of that x. Good. Well, if you don't get it, let me see your comment down below. Then I'm going to refer you back to my video which I talked about negative exponents. Anyway, okay, good. All right, thanks for watching. Please subscribe to my channel.